Hi everyone, in today's lesson we'll be taking a look at section 5.4 and our focus for today is the derivatives of exponential functions. We're going to start today with a definition and it says let u be a differentiable function of x, and in the first case we just have our basic exponential function e to the x. So its derivative is the same thing, the function itself. Now we know that x as the exponent won't always just be as simple as that. So in the second case, we have the derivative of e to the u, and its derivative is equal to e to the u, so the original function itself, times the derivative of that exponent. So you see e to the u times u prime. All right, so we are going to have a little bit of substitution today. So take a look at number 1. And we have y equals e to the 7x, and we're asked to find the derivative. So we are going to let u equal 7x, and that means that du would equal 7 dx. Okay, so let's take a look here. We're going to rewrite this as the derivative of y with respect to x, so we won't have a dx on the right-hand side, and that's going to be equal to the function itself, e to the 7x, times its derivative, which is just 7. And again, not writing the dx on that side because it's right here. Okay, we can write our final answer as dy over dx equals e to the 7x times 7, but we're going to put that 7 out in front. So final answer is 7e to the 7x. Okay, we are using that second rule, which says we're going to keep e to the u the same. So that's e to the 7x, our original function. And then we're going to multiply by the derivative of the exponent. And the derivative of 7x was 7. And then all we did was rewrite it with a 7 out in front of e to the x. Okay, in our second example, a little bit more complex. We have y equals e to the 5 divided by x squared. And I'd like you to rewrite it as y equals e 5x to the negative 2. All right, so we would let u be equal to 5x to the negative 2. And that means that its derivative, du, would be equal to 5 times the exponent, negative 2, times x now raised to the negative 3 power. And let's put du over dx here. So du dx would be equal to negative 10 x to the negative 3. All right, so what it looks like in the problem, taking the derivative of y with respect to x will give us the function itself, e to the 5x raised to the negative 2 power, times that derivative, 5 times negative 2 x to the negative 3. So it's the derivative of the exponent. And we simplify that to be e to the 5x to the negative 2 multiplied by negative 10 x to the negative 3. So we have a few things to clean up here. We're going to leave it dy over dx. Of course, you can have dy, you can have the dx on the other side. This negative exponent right here is going to cause the x to the third to go in the denominator of our fraction. The negative 10 is our coefficient, so put that negative 10 out in front. Put x to the third in the denominator. And we have e to the 5x to the negative 2. So we have a little issue here with this exponent. So I'm going to rewrite that final answer, one more step, as negative 10 e to the 5 divided by x squared power all over x to the third. Okay, in our third example, before we take the derivative, we're going to rewrite f of x as the quantity e to the x minus 3 being multiplied by e to the negative 2x. Bring that e to the 2x to the numerator by rewriting the exponent as a negative. Okay, so we want to distribute that. You could also take each term and divide by e to the negative 2x. All right, so I chose to rewrite it in the numerator, and then I'm going to distribute. So e to the x times e to the negative 2x. When you multiply those like bases, you're going to add the exponents. So it's going to be e to the negative 1x, or just e to the negative x. All right, to that we're going to be subtracting 3e to the negative 2x. And when we're taking the derivative, f prime of x, we are going to take the derivative of e to the negative x. So we'll keep the function the same and multiply by the derivative of the exponent, which will just be negative 1. Okay, so for this first term, it will simplify to negative e to the negative x. All right, from that we are going to subtract, and we have 3e to the negative 2x, so you keep the function the same, and now we have to multiply by the derivative of our exponent here. And the derivative of that exponent is negative 2. All right, we have a negative being multiplied by another negative, and multiply those coefficients together, it becomes positive 6 e to the negative 2x. All right, the only issue with these two is that we have negative exponents, so we want to rewrite it so that all of our exponents are positive. Okay, we had positive exponents in the original problem. We should have positive exponents here. So we're going to rewrite